Right now I'm about to fully discharge the battery and calculate the capacity and performance of the battery, and to see if the battery is good or not. Okay, so what I do is to discharge the battery, I'm taking 10 amps AC by 230 volt out of the battery, which is equal to 33 volt amps DC. Take a look out here. I'm taking almost 32 amp DC, 33 amp DC, which is equal to 10 amp, almost 9 amp AC. Look at here. I'm reading it's almost 9 amp AC by 230 volt. So after the calculation, it should continuously produce power to the load for 2 hours and 10 minutes. Okay, after the calculation, it should produce power 9 amp continuously for 2 hours and 10 minutes. Okay, so I put the timer and I'm gonna check whether it's a genuine battery or not. I'm gonna keep you posted. Let's check the voltage. Let's check the voltage of the cells. Right now I'm taking 32 amp, 33 amps out of the battery, the power wall, and the voltage is 52.6. And let's take a look at the temperature. I'm taking, let's say the temperature is good, 34, almost 34 degrees. The PCB 42. And let's take a look at the voltage, cell voltage. It is 32. Almost all of the cells are balanced. Okay, so the capacity is 98. So how did I did the calculation for the amount of time? Show you how did I do the calculation for that to know how many amps I can take for how many hours. Right now let's take this for example. This battery is 5 kilowatt hour. This is the energy. Okay, the energy storage is 5 kilowatt hour, and the state of charge, let's take a look at the state of charge. The state of charge of the battery is when I did the first time, it was 90%. Right now it's the 81%. Okay, so the state of charge, it was 90%. So what we do is 90. Okay, so we do 0.9. This is the state of charge by 5 kilowatt hour. Okay, 1 2 3. This is produce the actual energy storage of the battery. So we have 4,500 or 4,500 watt hour or 4.5 kilowatt hour. Okay, now we want to convert that to the amp hour. How do we do it? We divide that by the voltage, of the appliances, the AC voltage. So we divide that by 230. Okay, so we got 19.56 amp hour AC. Okay, so right now we have 90.56 amp hour AC right now. Okay, this is the amp hour AC. So we want to know the amount of hours the battery can take. Right now I'm taking 9 amp. As you can see, I'm taking 9 amp hour. It depends on how many amps you're taking. Right now I'm taking 9 amps out of the battery. See here, I'm almost a 9 amp. So we divide that by the number of amp we are taking. The amp hour divided by amp. The amp goes with the amp. The hour remains. So 90.56 divided by 9 is equal to how much? Let's go to 2.17. Let's say 2.10. Okay, that's 2.17. 2 hours and 17 minutes. Okay, 2 hours and 17. 2 hours and then 2.17. So the battery should continuously produce 9 amps AC for 2.10 hours. Okay, this is how you assess the battery energy and the battery capacity. Perform that capacity test and the energy test. We have to turn off the grid and turn off the PV, okay, the solar, and all the loads solely and only be on the battery, okay, the lithium battery. So as you can see here, I'm taking 32 amps from the battery. The voltage is 52.6. The cell voltage are 32. It's doing good so far. So far so good. All the voltage balanced. It's been 2 hours and 35 minutes and it's still pumping juice, and according to the calculation, almost 17 minutes left till it'll shut down. As you can see, now it's 50.7, 50.8, and I'm taking 35 amps, almost 9 amp AC, and capacity reached 3.9%. At the beginning it was 90%, now it's remained only almost 4%. So it tells me, according to this, it tells me 0 hours and 39 minutes left. I noticed one thing, and it's the cell temperature raised. As you can see, let's check the cell temperature, became 39, almost 40 degrees. That's a lot. Let's go on PCB board 46, in inverter is 44. The cell temperature at the end of the battery capacity raised. It's much higher than the beginning. Let's check the capacity. Only 1.9 remained, and it's going to shut down soon. Up to the here, this monitor shows that 0 hours and 43 minutes remained. Let's see how it goes. State of charge is 0% and remaining 0 amps, and the inverter, and it's still running. That's weird. That's awesome. That's beautiful. It should shut down by now because it's zero. State of charge is 0%, but it's still running and produces power. Let's see how many amps is how many AC amps is going through this. We have 7.3 amps. That's awesome. So that's great. Right now still running, and I'm taking 7 amps out of the battery, and the state of charge is 0. Let's take out the voltage is 50 volt. I'm taking 34 amp DC. Check out the cell voltage, 3.1. The cell voltage, the fully charged cell voltage was almost 3.3. Now it became 3.1, and that's awesome. And the battery is still running. Up to this, the monitor should run 0 hours and 36 more minutes. The system just now shut down, and the voltage is 46 volts, 0.24, and the temperature is 40 degrees. That's a lot. Okay, PCB board should be 48 degrees. The cell voltage, just it totally shut down. The entire battery shut down. Oh, sorry. There's no power in it anymore. Yeah, it's dead. The battery totally shut down. I just turned on the grid, and battery was drained, totally discharged. And I'm gonna turn back on the battery and charge. Let's see, turn on the breaker and turn on the battery. Okay, there's some voltage in the battery. I'm gonna turn on the AC. Turn on the AC. Okay. Okay, it's shut down. Just turn on the inverter. And let's go ahead and turn on the AC input, turn on the inverter and the grid and the solar. Right now I'm going to turn on the inverter to be charged by the grid, and let's see how it goes. And seems like I don't know, just yeah, it's pumping juice to the battery, 32 amps, 33 amps. So I'm gonna lower the amperage right now to 10 amps max.